Hi guys, this is Algebra 1, Lesson 7-5, factoring x²+bx+c. In the previous lesson, we learned the basics of factoring polynomials. So today, we will see how we can factor a quadratic trinomial. So, you know what quadratic means? It has a power of 2. And trinomial means the polynomial has 3 terms. So we're going to factor a quadratic trinomial in the form of x²+bx+c in a standard form. First, we're going to start with explore and reason. Let's consider the following puzzles. Okay. Card number 1 says, what two numbers multiply together to equal 15 and add together to equal 8? So something times something is 15, and the same numbers add together to become positive 8. That would be 3 and 5, right? 3 times 5 is equal to 15, and 3 plus 5 is equal to 8. So yes, that's 3 and 5. What two numbers multiply together to equal 15 and add together to equal negative 16? So multiply to 15 again, but they add up to negative 16. What are other numbers other than 3 and 5 that multiply to 15? Maybe 15 and 1. But if you add them together, it's positive 16 instead of negative. So you'd have to make one negative. So if you make one negative though, if you multiply them, you get negative 15. So you'd have to make both of them negative, right? So negative 3 times negative 5 would be positive 15. And negative 3 plus negative, no, I'm so sorry. I was thinking something else. 15 and 1, right? So negative 15 and negative 1 multiply together to be 15. Negative 16 plus negative 1 is equal to negative 16. Okay. Number 3, what two numbers multiply together to equal negative 15 and add together to equal negative 2? So the same thing. We're multiplying them, but now the product is negative 15 instead of positive. And so one of them have to be a negative number. And they need to add up to negative 2. So 15 and 1 will not add up to negative 2. Think about 3 and 5 again. Which number has to be a negative in order for the sum to be a negative 2? The bigger number, which is 5, has to be a negative. So negative 5 times positive 3 is negative 15. Negative 5 plus 3 is negative 2. And so negative 5 and 3. Number 4, what two numbers multiply together to equal negative 15 and add together to equal negative 14? So again, we're looking at the factors of 15, but one of them has to be a negative. And they add up to negative 14. So we're probably thinking of 15 and 1. And because the sum is negative 14, the greater number, 15, has to be the negative number. So negative 15 times 1 is equal to negative 15. And negative 15 plus 1 is equal to negative 14. So the answer would be negative 15 and 1, negative 5 and 3. And negative 15 and negative 1 for number 2. Okay. So we're looking at the factors of 15 here. And that was part A. Find the solutions to the 4 puzzles shown. Part B, write a set of 4 number puzzles of your own that have the same structure as these 4. Describe the pattern. So what are the patterns that we see? What is the structure that we see? all of these puzzles ask for factors of 15. And they give you a multiple of that and a sum of two numbers, two factors, right? So we can start with identifying the structure. All of the puzzles in part A ask for factors of 15. We can write similar puzzles for factors of other numbers. So for example, so you can pick your own number, but as an example, we can have a factor of 21. So think about factors of 21. You have 1, 3, 7, 21, right? And then you can come up with some examples and puzzles like that. Maybe 3 and 7 multiply to 21, but they add up to 10, right? Then you can make one negative. You can make one positive as well. So think about -1, -3, -7, -21 as well. And think about the combinations of those. -3 times 7 is -21. -3 plus 7 is 4. So you can write a question according to that. What two numbers multiply together to equal -21 and add together to equal +4. Okay, that could be 1. And then you can continue making other questions. Like, what two numbers multiply together to add to equal +21 and add together to equal 22. So that would be 21, +21 and 2, right? So you can come up with these puzzles as well and answer them. -3 and 7, and that would be 3 and no, that would be 21 and 1, right? And so on. All right, so that was a good intro for this lesson. The essential question for this lesson would be, how does recognizing patterns in the signs of the terms help you factor polynomials? So let's start with example 1. Understand factoring a trinomial. How does factoring a trinomial relate to multiplying binomials? So let's first look at an example, okay? Let's consider binomial product x plus 2 times x plus 3 and the trinomial x² plus 5x plus 6, okay? So if you multiply the binomials, x plus 2 and x plus 3, you can multiply both of them out, x with the x and x with the 3, 2 with the x, 2 with the 3, yeah, x² plus 3x plus 2x plus 6. That's equal to x² plus 5x plus 6, because 3x and 2x are like terms, right? So if you look at these numbers, x plus 2 and x plus 3, we can try to figure out some patterns. 2 times 3 is gonna equal to 6. 2 plus 3 is equal to 5 here. Do you see some connections there? And does that work for all of the binomial products? So there is a rule that there's a pattern for the binomial products. You can test it out as well. So if you want to see another example, we can come up with another example. So try x plus 1 and x plus 4, okay? We can say x squared, we can multiply that out. X squared plus 4x plus x plus 4 is equal to x squared plus 5x plus 4, okay? And compare the numbers, 1 and 4. If you multiply them, you get 4 here. If you add them, you get 5 here. Do you see that? And that pattern continues. So the sum of second terms of the binomials is equal to the coefficient of the second term of the trinomial. And that only works when you have a binomial product. So x plus a number times x plus a number, okay? So when factoring a trinomial, you can work backwards, try to find the related binomial factors whose product equals a trinomial. So x squared plus bx plus c is the form that's equal to x plus p times x plus q, where pq is equal to c and p plus q is equal to b, okay? So let's try to use that and apply that with some problems. Okay, so what's the factored form of x squared plus 5x plus 6? Identify a factor pair of 6 that has a sum of 5. So factors of 6 could be 1 and 6, 2 and 3, and the sum of them would be 7 and 5. And you can later think about the negative numbers as well, but they're all positive, right? 5 is positive here. In the form of x squared plus bx plus c. So right now we're looking at 5 and we want to match 5 from the multiplication c, because if you look at this, b is the sum of p and q here, and c is the multiplication, is the product of p and q. So if 5 is the sum of two factors that multiply to make a product of 6, then you can think of the factors of 6, right? That's why we're figuring out the factors of 6. And the sum of factors of 6 that makes 5 would be 2 and 3. And so you'll get x plus 2 times x plus 3. That's going to be equal to x squared plus 5x plus 6. Okay, so if you know this rule and if you get used to it, this is a great shortcut that you don't have to solve everything step by step. So if you factor using algebra tiles, you can look how it's done. X plus 2, x times x is x squared. X times 3 is 3x's. X times 2 is 2x's. And then 2 times 3 is 6. So all of them together would be x squared plus 5x and 6. Okay, so the factor form of x squared plus 5x plus 6 is x plus 2 times x plus 3. So now we're working backwards. We're going to factor it out, factor the polynomials out. Okay, and you can check by multiplying them out and see if you get the same answer as the original polynomial. And yes, it does. Okay, now it's your turn. Please solve try number 1A and B. Pause the video and come back when you're ready for answers. Okay, are you ready? So what are you looking for? What's the first thing that you need to look for? You need to look for factors. Factors of what? Factors of the last constant, the constant in your polynomial, right? So factors of 36 would be 1, 2, 3, and then 6, right? And then 12, and then 18, and then what? 36. There you go. And then you want to figure out the sum of two factors here that makes 13 here, right? So 6 times 6 is 36. 6 plus 6 is 12. So it's close, but not really. Okay. 12 times 3 is 36. If you add them, it's 15. So no. 18 times 2 is 36. 18 plus 2 is 20. So no. 36 and 1, 37. No. So how do you know? Are there any other factors that we haven't thought of? Yes, there actually is. I forgot. 4 and what else? 9. Yes. So 4 and 9 multiplies to 36 as well. 4 and 9 adds up to 13. So you have 4 and 9 as your second part of the polynomial of the binomials. Okay. All right, so part A is x plus 4 times x plus 9. If you wrote x plus 9 times x plus 4, it doesn't matter. It's the same answer, okay? Whatever you write first, doesn't matter. As long as you have parentheses x plus 4 times parentheses x plus 9, that's correct. Part B, what two factors multiply to 28 and add up to 11? So 28 has factors of 1. So in order to make sure that we don't forget all the factors, I'm going to divide 28 by 2. Okay. And then divide that by 2. And then we have 7, right? So we have 2, and then 7, and then 4. Actually, 4 and 7, I want to write it in order. 2 times 7 could be 14. And then you have 28, right? So 7 times 4 is 28, 14 times 2 is 28, 28 times 1 is 28. And you can think about all the combinations that you can make with the factors you have here. That's the prime factorization. All right, and then looking at these factors, what two numbers multiply to 28 add up to 11? 4 and 7? Yes, 4 and 7 works. So your answer is x plus 7 and x plus 4. Okay, let's look at example 2. Factor x plus 2, x squared plus bx plus c when b is less than 0 and c is greater than 0. So that means when the second term is negative and your constant is positive. So for example, what's the factor form of x squared minus 11x plus 18? So now we see a negative coefficient. Okay. So you're thinking of factors that multiply to 18, positive 18, that add up to negative 11, right? Why are we looking at both negative factors here? Why do both factors need to be negative? Because b is negative and c is positive. In order for you to multiply to get a positive 18, you have to have negative times a negative, right? So you're looking at two negative factors that add up to a negative number. They can't be positive because they have to add up to negative number, right? So so even though there are more factor pairs for 18, there's no need to continue once you find the correct sum, like -2 and -9, and that adds up to -11 and multiplies to positive 18. So you can just put that in your second term of the binomials. So x minus 2 times x minus 9 would be your answer. Okay. So pause the video now, try number 2A and B. Come back when you're ready for answers. Okay, are you ready? So 2a, x squared minus 8x plus 15. What two factors of 15 multiplies to positive 15 and adds up to negative 8? Negative 3 and negative 5. So yes, correct. X minus 5 times x minus 3 would be your binomials that are equal to this polynomial. 2b, what two numbers multiply to positive 42 add up to negative 13? Negative 7 times negative 6 is positive 42. And if you add them, they're negative 13. So x minus 7 times x minus 6 would be equal to x squared minus 13x plus 42. Okay, good. Let's go to the next page. Example 3. Factor x squared plus bx plus c when c is less than 0. So what if you have a positive b, but c is negative? So for example, what's the factor form of x squared plus 5x minus 6? So what are the factors of negative 6? It should be, one has to be negative, one has to be positive, right? Why do the factors have opposite signs here? Because b is positive and c is negative, right? So they need to multiply so that it's negative, which means one has to be negative, one has to be positive. But b is positive, so the positive number has to be greater. Okay, so for example, 1 and negative 6 multiplies to negative 6, but it doesn't work when you add it up, you get a negative 5. But 6 and negative 1 multiplies to negative 6, and if you add them, it's a positive 5. So 6 has to be the positive number. Okay, so the factor form should be x minus 1 times x plus 6. So now it's your turn. Try number 3A and B. Pause the video, come back when you're ready for answers. Okay, are you ready? What two numbers multiply to negative 14 and add up to negative 5 in 3A? So yeah, 7 and 2. Which one is negative? Negative 7 times positive 2 is negative 14. Negative 7 plus positive 2 is negative 5. So that's equal to x minus 7 times x plus 2. Okay, 3b. X squared plus 6x minus 16. What are two factors of 16 that multiplies to negative 16 and adds up to 6, positive 6? Okay, 8 and 2. Which one is the negative? If you have to add up to a positive number, your 8 is greater number, that has to be a positive. So x plus 8 times x minus 2 would be the two binomials that are equivalent. Okay, check your answers. And now let's move on to example 4. Factor a trinomial with two variables. How does multiplying binomials in two variables relate to factoring trinomials? So consider the following binomial products. So binomial products don't have to always be x and a constant, right? So what if x plus 2y is multiplied with x plus 4y? And that's equal to x squared plus 6xy plus 8y squared. Does that go along with the pattern we've been using? Look at the product. That should be the C, right? Part. And then this is B in front of your variable. So 4y times 2y becomes 8y squared. And yes, that is the product of 4y and 2y. If you add them, 2y and 4y, then you get 6y. So 6y and then times x is your second term. And so yes, it follows the pattern that we've been using, right? So now it's really the same thing. Factoring trinomial with two variables are also the same as factoring trinomial with one variable. You just need to be careful about what you're multiplying and what you're adding, okay? And they need to be like terms, because if they're not like terms, you can't add them. So yeah, and if you see a binomial times a binomial where you see a like term on your second terms and the same variable on the first term, that's when you use this rule, okay? So each trinomial will have the form x² plus bxy plus cy squared. Okay, it looks a little bit complicated, but if you separate your second term with the variable and the constant times the variable that you have for the first one, usually x, then you'll be able to see the pattern, okay? So look at the form and identify the parts, okay? You need to be able to identify the two variables and B and C. All right, let's look at an example. What's the factor form of x² plus 10xy plus 24y squared? First, identify a factor pair of 24 that has a sum of 10. Okay, we want to get a factor of this, but first, we're just gonna look at the number 24, okay? Identify a factor pair of 24 that has a sum of 10. So the numbers have to match up as well. 6 and 4 multiplies to positive 24 and adds up to positive 10. And now that should be enough, because y squared, y times y is y squared, and y plus y is 2y, right? So you need to look at the form here and figure out what are B and C. So the factored form should be 4y and 6y. And you can check. x² plus x times x is x². X times 6y is 6xy. 4y times x is 4xy. 4y times 6y is 24y squared. You add the like terms, 6 and 4, you get 10xy. And it's the same as your original polynomial, right? Okay, there you go. So yeah, this works for the numbers as well. If you have a variable, because when you add the like terms, right? When you add 4y plus 6y, you already have 10y. So here, you're not adding 1y and 1y to get 2y, but you can look at the numbers, the coefficients in front of the variables to figure it out as well. So it's really, you're doing the same thing, but if you have, yeah, as long as you have y here and then y squared, your B and C are still going to be the numbers, okay? All right, let's look at try number 4A and B. Try to figure out the factor form of the trinomial using the coefficients, okay? If they're in the form of x² plus bxy plus cy squared, then you can do the same thing where you could just identify the coefficients and figure out what multiplies to C and adds up to B, okay? Pause the video and come back when you're ready for answers. Okay, are you ready? So what two numbers multiply to positive 32 add up to 12? 16 times 2? No, 16 plus 2 is 18, so not 12. 8 times 4 is positive 32. 8 plus 4 is 12. So 8 and positive 8 and positive 4 works. That means you're going to write the binomial. It's not just x plus 4 and x plus 12, x plus 8. What are the form? Because you have x squared and then xy and y squared here, you need to write the binomial in its form as well. So you need to have, where's the form? Okay, so the form is x plus p and q, py times x plus qy, okay? Where p times q is equal to c, p plus q is equal to p in the form x squared plus bxy plus cy squared. Okay. All right. So for your binomial answer, you have to write x plus 8y times x plus 4y here. All right, part B, two factors that multiply to 21, positive 21, and add up to negative 10. Negative 3 and negative 7, right? Negative 3 times negative 7 is negative 21. Negative 3 minus 7 is negative 10. Okay, so you have x plus negative, let's get rid of the plus. X minus 3y times x minus 7y, okay? All right, if you got both of them correct, good job. You've got it. You know how to factor the trinomial as well. Let's look at example 5, application example. Apply factoring trinomials. Benjamin is designing a new house. The bedroom closet will have one wall that contains a closet system using 3 different size storage units. The number and amount of wall space needed for each of the 3 types of storage units is shown. What are the dimensions of the largest amount of wall space that will be needed? Okay. So he is designing a new house. If you see the picture here, it has one wall that contains a closet system using 3 different size storage unit, which is different, right? X times X, 1 times 1, 1 times X, but they're kind of related, right? There's X, there's 1. The number and amount of wall space needed for each of the 3 types of storage units is shown. That's 1 unit. And this 35 units. And 12 units of this we needed. What are the dimensions of the largest amount of wall space that will be needed? So first, the largest possible closet storage system will use all of the units. And so write an expression that could represent the wall area of the closet in terms of the storage unit. So the area for this one would be x squared. The area for this one is 1. Area for this one is x. You see that? So you need 1 unit of x squared, 35 units of 1 feet, square feet, 12 units of x square feet. So write that down. We need x squared plus 12x plus 35, all in square feet, right? So combining the units, like the number of them, and then with the area, we can come up with this trinomial. And because the area of the rectangle is a product of the length and width, factor the expression to find binomials that represent the length and width. So we want to factor it out so that, why? Because this is the total area we need. But if we factor it out, come with a pretty binomial, then we can figure out the length and the width of a perfect rectangular storage space that could fit into a wall. So we want to figure out, so this x squared plus 12x plus 35 all needs to go in the area of that. But why are we factoring? So that we can get the width and the length, because width times length is this, right? So if we factor it out, we can figure out the width and the length, okay? So that's our plan. So figure out the factors of 35, positive 35 that has a sum of 12. So it turns out 5 and 7 multiplies to 35 and add up to 12. And so if you factor it out, you get x plus 5 and x plus 7. So your width is x plus 5, your length is x plus 7, whatever your x is, okay? So the dimensions of the largest amount of wall space that will be needed are x plus 7 feet and x plus 5 feet. So notice that the unit for the area is square feet, okay? Dimensions for width would be just feet, okay? This feet times this feet becomes this square feet, okay? So that is your answer. The whole sentence is the dimensions of the largest amount of wall space that will be needed are x plus 7 feet by x plus 5 feet, okay? So after you figure out the factors, you need to see what it means in your original situation. Oh, that's gonna be width and length. And that's the largest amount of wall space that we'll need for the storage area, okay? All right, let's look at try number 5. What would be the dimensions of the largest wall area you would need if you use 11 of the 1 by 1 feet, 1 foot by 1 foot units while keeping the other units the same? So all of the other units, we need the same of those. So x squared, 1 unit of x squared, 12 units of x. But what if instead of 35 units, we just wanted 11 of the 1 square feet? Then how would your equation change? How would your factors change? So pause the video, see if you can figure it out by yourself, factor it out, and interpret, come up with a solution at the end. Okay, are you ready? So what is the equation that you came up with? So if you're changing the unit of 1 by 1, instead of 35, you're writing the same polynomial, except your 35 becomes 11. And so that's equal to what two binomials? So something times something is 11. And the same numbers add up to 12. So 11 times 1 should be 11. 11 plus 1 should be 12. So you're writing x plus 11 times x plus 1. So what does that mean in your situation? You're not done until you write the final answer down in the sentence. The dimensions of the largest amount of wall space that will be needed are x plus 1 feet by x plus 11 feet. Okay, and that is your final answer. There you go. All right. That was example 5. Let's summarize our lesson. So factoring the polynomial in the form of x squared plus bx plus c. Remember, your x is a variable. B and c are constants. their numbers, okay? To factor it, you find a factor pair of C that has a sum of B. And then you can use that to write the binomial with B and C as your second terms in the binomials, right? So when B and C are both positive, if B and C are both positive, your P and Q are going to be, the second terms of the binomials are going to be both positive, right? So if they're both positive, they're going to be both positive. And when B is negative, C is positive. So when B is negative and that's positive, you might have negative times negative in order to add up to a negative number. So they're both negative, okay? But when C is negative, that means the second terms of binomials have opposite signs, okay? Why do we not care what B is when C is negative? Because when C is negative, they will always have opposite signs, and your B might be positive or negative depending on what number is the greater one, okay? So yeah, when C is negative, it doesn't matter what B is, the second terms will always have opposite signs. All right, that was lesson 7-5, factoring a special polynomial. In the next lesson, 7-6, we'll factor a different term where we have a constant in front of x squared. So what if your x squared is not just 1x squared? That is going to be covered in the next video. So if you have any more questions, please feel free to ask Ms. King in class. Otherwise, I'll see you guys in the next video. Bye!